When you sketch the scatter diagram in your script, you need to take note of the following points. 1. Make sure that you have the correct number of points in your sketch. Also, you need to label the coordinates of the two extreme points, as shown on the screen. 2. Make sure that the axes are labeled with the correct variables, which are x and y in this case. 3. Make sure that the data points are positioned correctly, relative to one another. For example, since the y-coordinate of each data pair is smaller than the y-coordinate of its preceding data pair in this example, each data point should appear lower than its preceding data point. You need to pay attention to the relative spacing between each pair of data points in your scatter diagram as well. For part 2, observe from the scatter diagram that the data points are almost collinear, and lie very close to a common downward sloping line. Hence a possible relationship that can be stated is as follows. An increase in x results in a proportionate decrease in y. Or we could say that there is a negative linear relationship between x and y. For part 3, note that y may decrease during this period of time, perhaps because there has been a campaign recently to promote awareness on the importance of road safety. On the other hand, x may increase over the same period of time, perhaps due to the cafe expanding its business during this period. As such, if we plot the scatter diagram for y against x, we may observe a scatter diagram similar to the one in this example, but clearly, the increase in the number of outlets of the cafe did not cause the decrease in the number of car accidents. For part 4, 8, the concentration of a substance in a solution, y, will vary as time, x, passes. Hence, in this case, x is the independent variable, and y is the dependent variable. For part 4, b, the temperature, x, is affected by how fast the wind is traveling. Hence, in this case, x is the dependent variable, and y is the independent variable. Lastly, for part 4, c, there is no apparent influence by a student's English test score, y, on his or her mathematics test score, x, or vice versa. Hence, in this case, there is neither an independent variable, nor a dependent variable. As we have seen from example 1.1, while there may appear to be a mathematical relationship between two variables, it does not mean that there is a relationship in reality. Also, the appearance of a mathematical relationship does not imply that there is a causal relationship. An increase in one variable does not necessarily cause an increase or decrease in the other variable. For example, the appearance of a trend between the number of car accidents and the number of outlets of a cafe could very well be a result of a coincidence of two events occurring during the same period of time, and certainly it is not valid to say that the changes in values of one variable will cause changes in value of the other.